In this lesson, we'll continue working on problems involving the fact that the limit as theta goes to 0 of sine theta over theta is equal to 1. Our next problem is the limit as t goes to 0 of the tangent of 4t over the sine of 3t. So the first thing that we'll do here is go ahead and rewrite tangent in terms of sine and cosine. So we have the limit as t goes to 0. Remember, the tangent of x is sine x over cosine of x. So this becomes the sine of 4t over the cosine of 4t all over the sine of 3t. So first let's just rewrite this as a simple fraction. So this is the limit as t goes to 0 of the sine of 4t over the sine of 3t times the cosine of 4t. So we need to think about what this limit is equal to. So first of all, as t goes to 0, 4t also goes to 0. So cosine of 4t, that's just going to the cosine of 0, which is equal to 1. So this gives us the limit as t goes to 0 of the sine of 4t over the sine of 3t. So now let's think about what happens as t goes to 0. So as t goes to 0, sine of 4t goes to sine of 0 or 0, and sine of 3t goes to sine of 0 or 0. So this is going to 0 over 0. We don't know what that is, so we'll need to continue working, ideally, if we can, using our fact that the limit as theta goes to 0 of sine theta over theta is equal to 1. So now let's proceed like we did in our previous problems. So in order to work with this sine of 4t, if I had sine of 4t over 4t, then I could use my sine theta over theta result. So I'm just going to multiply this by 4t over 4t. And again, I'm just multiplying by 1, so I haven't changed the result. And similarly, I'll go ahead and multiply by 3t over 3t so that I have something to work with my sine of 3t term. So now let's look at what we have. So we get the limit as t goes to 0. So I have a sine of 4t over a 4t term, so that takes care of this term and this term. I also have a 3t over a sine of 3t term, so that took care of this term and this term. And then finally, I have a 4t over 3t. Okay, so I've taken care of all of my terms. Now, as t goes to 0, I know that 4t also goes to 0. So for this first expression, limit t goes to 0, sine of 4t over 4t, I can use my result with 4t in place of theta. Since 4t is going to 0, I have the limit theta goes to 0, or limit t goes to 0, sine 4t over 4t. So this first guy is going to 1. Now the 3t over sine t, I'm not sure what we're going to do with that yet, so I'll just leave it. Our 4t over 3t, my t's cancel, and I just get a 4/3. So far we have the limit as t goes to 0 of 1 times 3t over sine 3t, and then we have this 4/3 hanging out on the end. Now let's think about our 3t over sine of 3t. So I know that the limit as theta goes to 0 of sine theta over theta is equal to 1. So that tells me that the limit as theta goes to 0 of theta over sine theta, so instead of 1, I'm just flipping my limit, so I have 1 over 1, which is of course still just 1. So if this limit as theta goes to 0 sine theta over theta had been, for example, 5, then the limit as theta goes to 0 of theta over sine theta would be 1 over 5, or 1/5. Because the original limit is 1 and 1 over 1 is just 1, we get that the limit as theta goes to 0 of theta over sine theta is also 1. So now I know that as t goes to 0, 3t is also going to 0, so I can use this theta over sine theta limit with 3t in place of theta. So I get that this limit t goes to 0, 3t over sine 3t, that guy is also equal to 1. So in the end, we just get 1 times 4 over 3 or 4/3 as our limit. Let's do another example problem here. So here we have the limit as theta goes to 0 of tangent theta over theta squared times cotangent of 3 theta. Now, as we saw before in our previous problem, let's just start this by go ahead and writing everything out in terms of sine and cosine. So I get sine theta over cosine theta for my tangent, and then I have a theta squared, so I'm going to write that as theta times theta, and then cotangent 3 theta, so that's cosine 3 theta over sine 3 theta. So again, let's just get a simple fraction, so we get the limit as theta goes to 0. So now I have on the top, I have a sine of theta. In my numerator, I'm going to have that denominator, my cosine theta, and then my theta squared, so times theta, and then this fraction in the bottom will actually flip, so that sine of 3 theta will come up, and I have a cosine 3 theta in the denominator. So now let's see what we can figure out. So first of all, my sine theta over theta, we know as theta goes to 0 that that's going to go to 1. Similarly, as theta goes to 0, cosine of 0, that term goes to 1. As theta goes to 0, 3 theta goes to 0. So again, I get a cosine of 0, which goes to 1. So far, we've got the limit as theta goes to 0. So my sine of theta over theta, that went away, it just went to 1. So in the numerator, I just have a sine of 3 theta, and in the denominator, cosine theta went to 1, the theta went away with my sine theta, and the cosine 3 theta goes to 1, so I simply have a theta in the denominator. Now with my sine of 3 theta, as theta goes to 0, 3 theta goes to 0, so if I had sine of 3 theta over 3 theta, then I could use my result. We just have a theta in the denominator, so I'll multiply top and bottom by 3. So we get here the limit as theta goes to 0 of 3 sine 3 theta over 3 theta. Now I can use my result, which says that the limit as theta goes to 0 of sine of a quantity over that same quantity goes to 1. So as theta goes to 0, 3 theta goes to 0, so I can use our property and say that this guy goes to 1. So we simply get 3 times 1, or 3, for this limit.